According to data from the World Health Organization, influenza remains one of the world's greatest public health challenges. Every year across the globe, there are an estimated 1 billion cases, of which 3 to 5 million are severe cases, resulting in 650,000 influenza-related respiratory deaths. Additionally, almost 4 million people die annually from respiratory diseases. And this is just the reported data. It is predicted that at least 30 new diseases have emerged in the last 20 years. These include the H1N1 virus known as the swine flu, SARS, and MERS, which all threaten the health of hundreds of millions of people each year, not to mention the major economic losses incurred through sick leave and how sick it leaves many of those who do manage to survive it. For many of these diseases, there is no cure, no treatment, and no vaccine. Airborne transmission occurs when bacteria or viruses travel on dust particles or on small respiratory droplets that may become aerosolized when people sneeze, cough, laugh, or exhale. In these motions, tens of thousands of tiny droplets are released into the environment. They hang in the air much like invisible smoke. They can also travel on air currents over considerable distances. These droplets are loaded with infectious particles. These droplets can enter the body of another person through their mouth, nose, or eyes and make contact with this person's respiratory mucous membranes. A virus is so small that it's almost invisible to even a bacterium. This is how it is able to infect the tiny bacterium and the cells in our bodies. Unlike the bacterium, the virus has no cytoplasm or a nucleus or anything resembling a cell. It has a very basic structure of DNA covered by an outer protein shell and some fats. That's why viruses can't even be considered organisms at all. They're not actually living. They float around like debris in space, waiting to contact a host. Only once they enter a cell can they reproduce, and this is where the true terror of viruses is seen. Once inside, the virus hijacks the cells of their host by entering into the cell membrane, taking over the protein building structure of the whole cell, forcing them to replicate the virus instead. The cell then begins manufacturing an army of the virus until the entire cell is infected. It continues to replicate the virus until it explodes, releasing the virus to infect the nearby cells around it. This is how an infection spreads. This opens the door for other pathogens like bacteria to enter the body and cause infections, including pneumonia, which could be fatal. When tissues are inflamed, this prompts the infected person to cough or sneeze. Huge quantities of the virus are then released back into the environment to potentially infect people nearby, ultimately extending the spread of the virus. Airborne influenza is among one of the fastest spreading viruses. Type A influenza viruses are classified into subtypes such as H1N1, H3N2, H5N1, or H7N9. The letters and numbers that make up the subtype names are based on the hemagglutinin H and the neuraminidase N proteins, which look like spikes on the surface of the virus. Numbers added after the H and N indicate which order these proteins were discovered. There are continuous changes in the H and N proteins. Any change results in a different virus. Influenza A and B cause annual pervasive epidemics known as seasonal influenza and are grossly underestimated as killers. To aid in protection against airborne viruses, vaccines are developed as an active, offensive strategy. These unfortunately take a large sum of money to successfully produce and years to develop and test. In this time, as we wait for the vaccine, people succumb to the virus itself and perish before help can get to them. Vaccines can also harm you with unpleasant side effects even once they have been produced. Once produced, vaccines don't always reach everyone who needs them in good time. Many people believe that antibiotics kill a virus, but they kill only certain bacteria. Antibiotics cure infections, but for years we have taken too many of them. We even take them in through the food we consume. Prescribed antibiotics are often used for the flu or a common cold, for which they do not work. This has made many bacteria resistant to antibiotics, which means that antibiotics will no longer work. Unfortunately, the overuse and misuse of antibiotics are actually making bacteria grow stronger and more resistant to antibiotics, and there are few antibiotics being developed. What can we do to protect ourselves and our families? We are told to adhere to social distancing protocols. We are told to clean regularly, wear masks, and wash our hands with soap and hot water. We are told to use hand sanitizers and to treat surfaces with disinfectants. But what about the air? Chlorine dioxide, ClO2, is a powerful oxygen-based sterilant proven safe and effective even in a low concentration as a disinfectant, sanitizer, tuberculoside, viricide, fungicide, algicide, slimicide, or deodorizer. It has a wide range of applications in food and beverages, in the medical industry, and in personal hygiene products. MYAIRSHIELD is an advanced device that aids in disinfecting the air you breathe by spreading an atmospheric shield of chlorine dioxide, ClO2, one of the best agents against microbial life. MYAIRSHIELD, your 90-day portable, active air disinfectant to help keep the air around you and your family safer. Your invisible defense against invisible enemies.